Viitorul e al tău, noi punem temelia. UTCB, construim pentru România. UTCB, Universitatea de Construcții București.
Good evening. My presentation is about the local site conditions in ground motion simulations. We will see that we can learn a lot about the local site conditions through these simulations. I will talk about very briefly about the simulation method, and then I will talk about the difficulties of simulating the local site conditions. The local site conditions that I will talk about is from the Dacian Basin, from Bucharest, from the Cerc station, and the exemplification is made for 1977 earthquake, a 7.4 magnitude earthquake, and the 1986 earthquake, 7.1 magnitude earthquake. As we can see here, we can simulate ground motions with 4 methods. The best method that can simulate the uniqueness of Vrancea source and of Vrancea exposed area is a hybrid method where the source and the site and the path effects are introduced to a stochastic method of Bohr, the SMSIM modified method for Vrancea, and the soil effects are introduced to a numerical method from deep soil. The ground motion characteristics in the simulation method are introduced through the spectrum of ground motion in SMSIM and through the shaping window. When we go to the hybrid method, the source and the path characteristics are simulated when simulating the bedrock motion, and the local site conditions are simulated through the numerical method in deep soil. As general considerations, the south of Romania and the north of Bulgaria compose the Dacian Basin. And as we can see here, the Danube Valley is the portion with the smallest local site conditions depth. Also, we can see that Bucharest is almost in the middle of the basin. And we can see from from the Mania research, we can see that the bedrock depth varies from 2 kilometers, more than 2 kilometers, to several hundred meters in the basin. So this is not an ideal thing for Romania, as we can have in other seismic zones. We have only a few hundred meters of local seismic local site conditions. So in our case, parameters like VS30 may not work, and we will see they not work. Okay, so now I will discuss the issues about the simulating local site conditions, and we will discuss the depth of the profile definition, because we have many definitions for the same site, the magnitude dependence of the response site, the discretization, and the dynamic parameters. The Cerc site was characterized through 3 profiles, as we can see here, one more than 1 kilometer long from Constantinescu and Enescu, and 2 profiles more than 100 meters long from Neagu after Ardea and Lungu. The calibration of the simulation is made for the 1986 earthquake, the 7.1 magnitude earthquake, and the simulation was made through nonlinear analysis and equivalent linear analysis. If we look at the PGA from the bedrock to approximately 150 meters, the soil conditions attenuates the peak ground acceleration, and for the last 150 meters, the ground motion, the local site conditions amplifies the peak ground acceleration. So here we may ask ourselves if we should consider only the 150 meter depth for the local site conditions, but if we look at the spectral characteristics, we will see that shorter profiles, we can see here Negru profile and Lungu profile that is gradually completed with layers from Constantinescu and Enescu. And we see in purple is the only simulation that can see the amplifications for longer periods. So we must use the entire package of the local site condition, not only the first 150 meters. Here are simulations for different definitions from the profiles that I had. The best simulation was from Neagu profile completed with Constantinescu and Enescu. The comparison is based on a much more complex comparison I will show later. The profile that gave the best results is accordingly to Mania research. Other issues were the magnitude dependence and the discretization. Here we have two sets of simulations performed for the deepest layer, the Miocene layer, with several discretization. You can see there for 2 meters elements to 50 meters elements. The simulation were made using two types of bedrock motions with different source spectrum corner, 0.0 Hertz, simplified being lower magnitudes, and 0.13 Hertz, simplified being higher magnitudes. It's very simplified, this part. What I wanted to show you is that if we look at the graphs with the 0.09 Hertz, lower magnitudes, we do not see amplifications in longer periods. So lower magnitudes do not activate amplifications in the longer periods. So we should not extrapolate analysis from lower magnitudes to higher magnitudes earthquakes. As for the discretization, in the graphs from the below, we can see the simulation with the 50-meter element discretization, and we can see that this big discretization do not see the shorter periods, so we should use discretization as fine as possible. The last issue is the dynamic parameters. The analysis was made employing equivalent linear analysis and nonlinear analysis. I am sorry for that graph. The values are reversed on that graph. But because we talk about a very deep profile, I needed to use general definitions as Vucetic and Dobry and Sid and Idris. And if we see here, this is the comparison with the misfit, taking in considerations a lot of parameters for the simulations. The best results were given by the equivalent linear analysis, but if we look at the spectra, we can see that the results are better for the nonlinear analysis. This difference is probably because of the definitions and because I didn't have dynamic parameters for the profile. Okay, so the validation was performed for the 1977 magnitude earthquake, the 7.4 magnitude earthquake. And as we can see here, the results are very good, mostly when compared to the mean, but are very good when compared to each component in part. And as for the profile, we see the same tendency from the bedrock to approximately 150 meters. In the PGA, we see an attenuation, and then we see an amplification, and also we can see in spectra, we can see the amplification for the longer periods. So in conclusion, shallow depth geological profile does not generate the changes that we recorded for the longer periods. So we need to use the entire sedimentary profile of more than 1 kilometer. The local stratification response is dependent on source characteristics, so we should not extrapolate from lower magnitudes to higher magnitudes. The discretization controls the short periods components, and we need dynamic characterization because of this high thickness of superficial geology.
UTCB, viitorul e al tău, noi punem temelia. UTCB, construim pentru România. UTCB, Universitatea de Construcții București.